Okay, for lesson 6, we're going to use what we learned in 3, 4, and 5 in order to do some problem solving. So remember that the illustrations are not to scale. It would be the same thing on your tests and assignments, and they're just to give you a rough visual representation of what is taking place here. So for the first one, Carmen is a surveyor who is using a transit to determine the height of a tree. The transit is placed 52 meters from the base of the tree, and the angle to the top of the tree is measured as 12 degrees. If the transit stands 1.8 meters from the ground, then we're going to calculate the height of the tree to the nearest tenth of a meter. Well, I can see that there's this extra 1.8 meters that's going to exist here. This length along here is still going to be 52 meters. And so the first thing I'm going to do is I'm going to solve for the missing side of this triangle. Now remember, it's not going to include that 1.8 meters along the bottom, so we're going to have to account for that at the end. So in this case, if I know my angle is 12, I know my adjacent is 52, and I'm trying to solve for the opposite, I'm going to use my tan ratio. I'm going to say that the height of the tree is going to be based on tan of 12 is equal to the height of the tree, let's call it T, over 52, which means that T is going to equal 52 times tan of 12. And this is going to give me 11.1. Now, I also have this extra height at the base, so I'm going to say the height of the tree is equal to 11.1 plus 1.8. So the full height of the tree is going to be 12.9 meters. Now it wants me to determine the angle of the base of the transit with the top of the tree to the nearest full degree. Well, what I'm doing is I'm creating a new triangle in here. I'm going to start down at the base. It's going to cut all the way up here. And then I know that my new opposite side length is going to be 12.9. So I have my opposite of 12.9, I have my adjacent of 52, and I'm solving for what the new angle is created there. Well, I'm going to say that tan of, let's call this x degrees, is going to equal 12.9 divided by 52, or x degrees is going to equal tan to the negative 1 of 12.9 divided by 52. And in this case, that is going to give me an angle of 14 degrees to the nearest whole degree. For example 2, a circle with a center at C and a radius of 20 millimeters is tangent to the arms of POQ, this angle. If angle POQ, so the angle all the way through here is going to be 50 degrees, then determine the length of O to C to the nearest millimeter. Well, if I know that this entire angle is 50 degrees, then just this angle, because these two side lengths are going to be the same, is going to be half of that, 25 degrees. I know my opposite. If it's tangent, I've created a right angle here, and I'm trying to solve for my hypotenuse, which means that I'm going to be using my sine ratio. Sine of 25 degrees is going to equal my opposite, 20, divided by my hypotenuse, which in this case is going to be the length of OC. OC times sine of 25 is going to equal 20, or OC is going to equal 20 divided by sine of 25 degrees. That's going to give me 47 millimeters to the nearest millimeter. For example 3. In many problems, the angle of elevation or depression is determined from a person's eye level and not actually from the ground. In the diagram, the man on the ground is standing 12 feet away from the wall. And the angle of elevation from his eye level to his wife's is going to be 62 degrees. If the man's eye level is 6 feet or 6.0 feet off the ground, and his wife's eye level is 5.2 feet from the top of the building, determine the height of the building to the nearest tenth of a foot. Well, the first thing that we're going to do is we're going to solve for what the height is between their eye levels, using this adjacent height of 12 feet and this angle of elevation of 62 degrees. So if I'm trying to solve this, I'm solving for my opposite. And I'm going to say that tan of 62 is equal to my opposite divided by those 12 feet, or the opposite is equal to 12 times tan of 62. This is going to give me approximately 22.56 feet. I'm not going to round it too far just yet. Now, if I'm doing the total height of the building, I need to account for the height that exists on the top and the height that exists on the bottom. So I'm going to say the height of the building is equal to these combined heights, 22.56 plus the 6.0 feet on the base plus the 5.2 feet on the top, which is going to give me 33 point to the nearest tenth, 8 feet. And there's my height of the building. Now, there is a skill set that deals with bearings. You're not going to be tested on it, so don't worry about this part. And don't worry about this last question. We're not going to deal with bearings this year. You might write into it in grade 11. That also means when you get into your questions at the end, make sure that if you have any of these bearing questions, don't worry about the bearing questions.